Hello, good evening, good morning, wherever you are. Welcome to the Virtual Java User Group. The VJUG, we're an inclusive virtual community, if you don't already know that, and we focus on Java and associated technology. So if you don't live near an active Java user group, or you're just really thirsty for more high quality technical sessions, hopefully this is the place for you. My name is Mark Hazel. I'm one of the humans that helps to try and put this stuff together and work behind the scenes to hopefully make sure everything runs quite smoothly. In a few minutes or a few moments even, I'm going to hand over to our amazing event host for this evening, which is Alina Urenko, who's dev advocate for GraalVM at Oracle. A few bits of housekeeping beforehand. Slack is one of the best places to interact with us, our speakers and fellow community members. If you haven't already signed up, you can find the link on our meetup page. And also, helpfully, here on the screen right now. Joining the live session channel on Slack is one of the best ways to be able to ask questions. Alina will be able to see those. You can also post questions directly into the YouTube chat as well. We also love feedback so that we can carry on improving. You can find us on Twitter @VirtualJug, or on LinkedIn, just search for Virtual Java User Group, and you'll get all the updates on there. Thanks very much to our sponsor, Devox UK. Like Devox UK, the VJUG is a place where we aim to be vendor neutral and to share knowledge and best practices related to the JVM and surrounding technologies. Anyway, look, that's enough from me. I'm going to introduce you now to Alina. Alina, welcome.
Hi, thank you, Mark. Happy to be here, and thank you for a great intro.
Well, it's nice to see you again, and I'm going to disappear off stage so that you can do the important part of the evening.
Thanks. So hi again, everyone. My name is Alina. I'm a developer advocate for GraalVM at Oracle. Very happy to be here, see you all, and see so many people joining. And we will have a great topic today. There are many amazing frameworks in the Java ecosystem, and I mean it when I say I love them all. But the Spring framework and the Spring team have a special place in my heart. That's why I'm very happy that today we have a great guest. He doesn't need introductions. He is probably one of the most recognized, famous, and universally loved developer advocates out there. And that is the one and only Josh Long. Hi, Josh.
I think you were talking about Venkat. I was like, I
did say developer advocate, so I meant you.
Yeah, that's the only clue. Hi, Alina. Good to see you, my friend. Oh, yeah.
Yeah, long time no see, huh? Like a couple of hours, right?
Yeah, whole hours. You caught me drinking Java.
Java. Oh, that's so appropriate.
Mm-hmm. Oh,
okay,
yeah.
Guys, so the way this will work, we will, Josh will take it away and do the presentation. I'll talk about all the amazing recent features in Spring Boot since 3.0. And you can ask us questions on YouTube, on Slack, and then we will make sure to have time in the end for Q&A. And we will make sure to also have enough time for Josh to show us all the cool stuff. So Josh, can you do a little intro and teaser? What are the things that we will see today?
Well, so I was, what is I know I just asked, but it would be nice
YouTube
if we
link.
had, I want to like retweet it or something, you know? Yeah.
You can start with the intro, like what we'll see today. And let me see if I can get you the link.
Okay, sure. So today my expectation is to take us on a journey and to take a look at some of the latest and greatest in the wide and wonderful world of Springdom. And we'll do that, of course, by, just seeing things as they come. And I think it'll be fun. Fingers crossed. There's probably going to be some GraalVM.
I hope there will be GraalVM.
Yeah. Like I wouldn't dream of not doing GraalVM.
Okay, and if I can make a request, I would really like to see that Spring AI stuff because that's really cool.
Okay, I can do that too. Yeah, I love it. I love the AI stuff. Okay.
Okay, do you want to start screen sharing? I will bring your screen on stage if you're ready.
Yeah. Let me just switch tabs. There we go. Okay, sounds good. Is my screen visible?
Okay, you are on. Yeah, it should be visible. Let me move behind the stage so you can take it away.
Alrighty. Hi, everybody. Thanks for joining us today. I appreciate that. I'm so excited to be here. We have so very, very little time and so much to do, so let's get straight to it. My friends, I've never been more convinced, more excited, more enthralled by the state of the Java and Spring ecosystem. And there has never been, in my humblest of opinions, a better time to be a Java and Spring one developer. And to celebrate that, to put a fine point on that, I want to remind you, I was there for most of the history of Spring and and even more of the history of Java. And I say that fully cognizant of where we are in that spectrum, that continuum of change and innovation. And there, to celebrate that, we had this amazing website, spring1.io/history of Spring. We created this last year to commemorate the 20th anniversary of the first early access milestone builds of Spring Framework, which came out in 2003, and to celebrate the 10th anniversary last year of the first early access builds of Spring Boot. And this year we celebrate the 20th anniversary of the first 1.0 GA version of Spring Framework and the first 1.0 GA version of Spring Boot 10 years ago. So 20 years ago for Spring Framework, 10 years ago for Spring Boot. Both birthdays have already come and gone. They were in April and they were in March and early April. And so it's been an amazing ride. And, you can see the history of Spring. If you go to this little website here, the project was created, the team was formed, Spring Framework 1.0 released, and here Spring Security going down. We got some projects, some foundational projects, Spring Data, for NoSQL, Spring Boot 2014, Spring Batch, right? We got that. We've got Spring Integration, and now we're in the clouds. I hope that's not too subtle. Spring Cloud 1.0, 2015, Spring Cloud Task. We've got Spring Cloud Stream in 2016, Spring Cloud Data Flow going down, Spring Cloud Data Flow for Kubernetes, Spring Cloud Skipper. We got Spring Cloud Gateway for Kubernetes. We've got Spring Boot 3 and Spring Framework 6 in 2022. That's the new era, the modern era that we find ourselves in right now. And of course, we all win in this video game, right? Because we all get to move faster and further than ever before. And so I really think there's just never been a better time to be a Java and Spring developer. Truly an amazing moment. So to demonstrate that, let's build some software, as we always do, by going to my second favorite place on the internet. Anybody who knows me at all, knows what my first favorite place on the internet is. It's production. I love production. You should love production. You should go as early and often as possible. Bring the kids, bring the family. The weather's amazing. It's the happiest place on earth. It is better than Disneyland. But if you haven't already been to production, you can begin your journey here at start.spring.io. And here, friends, we have some choices we need to make. What build tool? I've already selected Maven, though Gradle is the default at this point. And then we have a choice of what we want to name our service. And friends, I am going to name my service because I'm great with names, amazing with names. I get that from my father. My father was also amazing with names. When I was a small boy, we had a small white dog, and my father named him White Dog. Absolutely amazing with names. That said, my mom, she tells me all the time, she says, "You're very lucky that I named you." And yeah, that's probably true. And then we have a choice about what version of Java to use. Friends, you see before you use Java 22, 21, and 17. There is no 8. There is no 8. 8 ain't great, right? Remember, 8.0 came out before Spring Boot 1.0 more than a decade ago. There's absolutely no reasonable reason to be using either Spring Boot 1.0 or Java 8 anymore, ever, right? They're completely antiquated, irrelevant pieces of code in today's world. People were doing the Ice Bucket Challenge back then. President Obama was still president in the United States, right? It's so long ago that it makes absolutely no sense to even consider it. So today, Spring Framework 6 and Spring Boot 3.0 require Java 17 or later. But my friends, I got to tell you, I wouldn't even bother with Java 17. Today, I'd be using at least Java 21. Java 21 is arguably the single most important release of Java in its history. And there's a lot of reasons for this, but the biggest, of course, is virtual threads. And I cannot stress this enough. You would be it's software malpractice if you could go to 21, but you chose 17 today anyway, right? You're leaving money, you're burning money. Okay, you got to be using Java 21. So let's build an application. We're going to use GraalVM's native image support. We're going to use the Docker Compose support, the web support, the Postgres SQL support, the Spring Data JDBC support, the dev tools support, the Docker Compose support. We already have that. Good. So I think we've got a lot of good stuff here. Docker Compose, Web, Postgres, Spring Data, DevTools, Web, GraalVM. I'm happy with my selections. Let's go ahead and, oh, you know what? I'm not happy. Yeah, I'm not happy at all. I forgot about this. One last thing. It's 2024. Where would we be without some AI? So let's go ahead and add OpenAI to the mix. Hit generate, and we're going to open this up in our application. So UAO service.zip. Here we go. Open that up. Service application. Voila. Okay, so let me make this font a little bit bigger. Zoom. Okay, and then make that. Let's see, is that big enough? That seems like it's big enough. Okay, good. So we have a public static void main. It's a data-centric application. To that end, we've got a Docker Compose file here that Spring Boot, the Spring Initializer generated for us. I'm going to modify it to export the port. I'm going to then disable the thing that Spring Boot sees to automatically start up the dependency, right? So I'll go ahead and do that, and voila. Okay. So now I've got a new build. I've disabled the automatic start and stop of the Docker Compose file, which means I need to do that myself. So I'll go here, Docker PS. Do I have anything? Nope. Docker Compose up. Okay. Let's go ahead and run that. Let it spin up as it needs to. Here we go. Good. So that's in the background. Now I'm gonna tell Spring Boot how to connect to that. So first we'll do some SQL stuff. So Spring Data Source password is secret. Spring Data Source username equals my user. Spring.url equals jdbc:/postgresql localhost. And it's my database, right? I'm going to do that. And then finally, I want to tell Spring Boot to initialize itself by evaluating some SQL data, some SQL files, some DDL files. I'm going to have two of them here. One of them is called data.sql, and another one is called schema.sql. Okay, so here I'll say create table if not exists, customer ID, serial, primary key, name, text, not null. Voila. Okay, and then for the data, we go over here. Okay, so delete from customer, insert into customer, name, values, and I'm just going to put some people on the Spring team. My name is Josh. It's so very lovely to meet you. We've got some amazing people on the team. Just listing a few of them. Who else? I guess we could, let's see. Whoop, some accents. I love that. Okay. Is that, what is that? Is that, that is 9, that's 8. That means if I divide this by 2 and then 2 again, it's still 2. Nice round number. I quite like that. Very good. Okay, so we've got our SQL application. We got some schema. We got some data. Now I want to build an application to describe that data. And I'm going to start, as always, with our entity. I'm going to build an entity here, like so, using Spring Data JDBC. I love Spring Data JDBC, and I love, 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 love records. I love them so much. Records are just one of my absolute favorite features in the language. And records are actually, you know, as trivial and small and slight as this is, make no mistake, records unlock a whole new world of opportunity. They're part of a number of features in Java 21 and later that the Java language team is calling data-oriented programming. And those to support that use case, we have a number of features: sealed types, records, pattern matching, and of course, smart switch expressions, right? So these things taken together are supporting what the Java team, like I said, is calling data-oriented programming. The genesis of this pattern is that historically, in the world of the monolith, Java has reigned supreme. It's quite good because it's got strong access control, privacy controls, a good compiler. It's fast. It scales well with large code bases. And so it's been a very natural fit in that world. In that world, you communicate, you introduce change into the system by introducing specializations of deep-seated abstract hierarchies of types, right? You create a new subclass of something, override some template method or whatever, and provide a new implementation. That's how you communicate a new change in behavior to the system. But these days, increasingly, the code bases on which we work are smaller, more focused, and increasingly, we communicate change as a new vector of functionality in the system by sending new messages, right? And increasingly, those messages are ad hoc, stringly typed messages coming off the network from a Kafka broker or a RabbitMQ or a REST endpoint or GraphQL or whatever. And the language has to support those use cases. And so it has a number of these different features. So let's just take a brief digression. And let's suppose I worked in a very heavily regulated industry, and I'm trying to build an application that deals with loans. And we want to be very clear about what we're doing and how with loans, right? Because again, heavily regulated instrument, a financial instrument in the banking industry, these have laws that attach to them, right? They're not just things that we're creating for our domain because it's cute. We're doing this because we want to have a very simple way to understand and track things that have legal consequences, right? So it's very important that when we create an implementation of this, that we don't have the ability to sort of create or to sidestep the regulation that we put in place. The last thing we want is somebody creating an anonymous inter-class implementation of that type that sort of sidesteps the validation logic that we've got in the system. So here I've got an interface loan, but I can create as many of these as I want right now. I want to put a stop to that. One way to do that is to use sealed types. Okay, so I'm going to say that I have 2 types of loans in the system. I'm only allowing these 2 types. So this is more granular than something very coarse-grained like public or private or package private or whatever. Here I can say I'm only allowing 2 other types. Well, the compiler's not happy. It's because these types can still be subclassed. So let's seal them, okay? And maybe for the unsecured loan, maybe this could be a record as well, right? So I'll say float interest, okay? Very good. So I've sealed them. Records are effectively final. You can add the keyword, but they're final anyway. It's redundant. And so now the compiler knows I only have 2 implementations of that type in the entire system. I don't need any more. And if I try and add more, it won't work. The compiler won't let me. So now I know exactly what implementations exist, and I can make sure, hopefully, that I'm handling all those use cases. So let's imagine I have a method here to display a message for a given loan type, right? So imagine I have a message like that, and I say, okay, if loan instance of secured loan var sl secured loan, I can downcast that, and I can say message equals good job, nice loan, right? Good stuff. Very, very friendly message there. Okay, what if instance of unsecured loan? Well, here I say message equals like this, and I'll get the unsecured loan. There we go, and I'll say message equals ouch. That USL.interest is going to hurt, right? So that's another message, and I can just return that message. But there's several problems with this code. It works, but what happens if I don't handle both cases? Nothing. The compiler doesn't care. It's not going to stop me. It doesn't care that I'm not handling both cases properly, right? So let's see if I can rework this. Also, maybe I could take advantage of pattern matching, right? Remember earlier, I talked to you about this record. Records are a contract that you make with the Java compiler. The stipulation here is that these are basically Java's answer to tuples. Tuples are containers with structured data in a given offset. And lots of other languages have these, but in Java, it's a nominal language. Everything has a name in Java. So we call our tuples with a name. One of the name here is an unsecured loan. This tuple has one component. We call that the interest field here. And if you add other things to the constructor like this, then those become other components that get added to the record. The contract with a record is that the identity of the unsecured loan is equal to the identity of all the different components passed into it, right? So put another way, if I have a reference to the interest and I stored that in a float, I can get back the exact same instance of the unsecured loan by recreating it by passing in that float interest into the constructor of another unsecured loan thing. It is identical. It is equal in identity, and this continues even if I add other constructor parameters, right? If you are willing to agree to this particular concession, if you're willing to say the identity of my record is equal to the sum of all the identities of all the components, well, then the language can do some really cool things for you. It can create a new class with a constructor with fields for storage, for accessibility. It'll create getters and setters and toString and hash code methods. And it'll do all of this in much less syntax, right? So this is actually a really good deal if you're okay with not having any derived state. Okay, very convenient. So now going back to this, the compiler knows about my unsecured loan and the fact that it's a record. And I can actually, the compiler knows a lot actually, and you can ask it to share some of that knowledge with you by using pattern matching, right? So in this case, it knows that if this is true, then within this block, I could downcast to a secured loan as I'm doing it right here. But if it knows, why don't I just piggyback on that, right? And that's called pattern matching here. What I'm saying is match this pattern and then extract this variable, right? So SL is equal to secured loan if this test is true, okay? Ditto for this unsecured loan. I go down here, okay, good. So now I'm saying if loan is instance of unsecured loan, then I have a pointer to USL and I can dereference the interest field. All right, that's fine enough, but I don't actually need the rest of the unsecured loan. I really just need the interest field. So here I can, again, I can use pattern matching like this, right? Okay, so I can say unsecured loan interest, right? And I'm passing in the interest as well. So this is very, very nice. I'm destructuring the unsecured loan, getting access to the component of the record, and then using that in the context of this if else. So pattern matching makes things a lot nicer, but still, look at that. I still have this problem where if I remove one, it doesn't get better. So and now I can actually use smart switch expressions. And here, with a smart switch expression, I am able to evaluate an expression and return that in the context of the branch that I'm evaluating in the switch. It's not a statement as it always has been before. It's a different syntax. Notice I'm using the arrow instead of instead of a semicolon, right? So here's a secured loan, SL. Okay, and then here's the other message there. Okay, and the other thing about this is that the compiler knows whether I've exhausted all possible paths, right? So let's consider cleaning this up a little bit here, just a little bit nicer. Very good. So it knows that if I don't handle this use case, that I haven't exhausted all the possible input values. And so I have to handle both of them. So now I've got a result that is safer because it's catching all the cases. It's cleaner. You can see it's much less code to do it this way. Much less code. It's faster, right? Because we're doing a switch, which is also much faster than an if. Remember, switches are basically offsets, right? They're much faster than if else's in bytecode and in native code and so on. And so this is actually a much better result all around, and it's using all these features. We got sealed types, we got pattern matching, we got smart switch expressions, and we got records, and these things play well together. It opens up a whole new paradigm. So yeah, don't sleep on the magic of the record here. It opens up doors like data-oriented programming. Okay, so back to our regularly scheduled programming. Let's create a list of CRUD repositories whose customer is the primary key, and the customer is the entity, and integer is the primary key. Very good. And now we're going to create a customer HTTP controller. Okay, I'm going to inject the customer repository as before. Very good. And customers, voila, and a collection, customer, very good. Return this repository find all. Whoa. Come on, computer. There we go. Good. So I've got my simple HTTP controller, right? And it's going to produce some HTTP JSON data there. Very simple, very easy to use. Now, I'm going to start the application up for the first time. I haven't started it up thus far, but I'm not going to do that again because I have dev tools on the class path. Dev tool sits there and it monitors the class path for any changes. And it recreates the class loader, loads the new classes, and it throws away the old one. The idea here is that it's much faster to restart and recreate the Spring application than it is to restart the JVM itself. The JVM is many things, but it is not fast, particularly to start up. But Spring is. Spring is very fast. So I'm going to just do that. Okay. So now I've got this application. Let's go to our browser here. Go here, customers. It worked. Of course it worked. Obviously it worked. It was a demo. That was always going to work. No, friends, that's old news. I mean, you could have done this 10 years ago, albeit with a lot more verbosity, right? Because you wouldn't have had records and the like. And indeed, you would not have even had Spring Data JDBC. You would have had to use something much more verbose like Spring Data JPA. Okay, so we have this very, very simple setup. But that said, friends, this is not particularly interesting. Like I said, you could have done this 10 years ago. This is a web app babysitting a database, not particularly interesting. But it is 2024, and AI is in the air. I'm actually in Paris, France, as I record this discussion with you. And here they have some really interesting entries in the AI space. You've got Mistral and Hugging Face, both of which have huge teams here. But generally, the center for AI in the world right now is San Francisco. That's where I live. It's a small city in the northern part of California. And right now, you can't walk around without talking to somebody or hearing somebody talking about their next AI side hustle. It is an energy I've never seen before in my 12 years living in the Valley and living in San Francisco. It's just an amazing, amazing time. And so AI is everywhere. I think about use cases all the time. And we have this amazing project called Spring AI. And it aims to support the entire pipeline. It aims to support the entire pipeline of finding data, ingesting it, storing it in a place that you can then query it, usually a vector store, and then connecting that vector store to your large language model, your LLM of choice. And Spring AI has integrations for all the different vector stores you can think of, all the different LLMs you can think of, and so on. That whole pipeline is very important because remember, when you use a large language model like OpenAI's ChatGPT or Gemini or whatever, they have a certain number of tokens to say, that is to say words that you can send and then receive from them at a time, right? And that token window determines how much data you can send there. Well, it's very important that you're able to send data because oftentimes these things don't know about the data that you want them to know about. So if you're trying to integrate them into your applications and your services and your systems and your software, you want them to be aware of the data that you're working with so they can make informed responses, right? And these LLMs often have a best by date or a fresh by date, right? These fresh by dates are the point after which they're no longer aware of what's happening in the world, right? They might have been trained on data up until 2 days ago, but after that, they don't know what's happening. And even if they did know what was happening, they certainly don't know what's happening, let's say, in your company's private Oracle or Postgres database, for example, right? You need to integrate them with that. And so the whole pipeline of finding data, getting it in a format you can search for it via a vector store, and then using that data to create a prompt, which you send to the LLM, which has data in the prompt that informs the response you get back from that LLM. That whole process is called retrieval augmented generation, RAG or RAG. And Spring AI supports all of that, right? It supports the entire pipeline. And there's some really amazing opportunities here that, I would love to see us execute on, and I would love to see people using. I mean, just think about it, right? Imagine you're using Spring Batch and you've got some invalid data, right? And normally in a Spring Batch job, you get to a row with bad data, you just mark it as invalid and you skip it, or you fail the job. What if there was a third option, right? What if you could send it to AI and have the AI try and clean the data for you, and that way the job can continue, right? Well, now you can write a Spring Batch job that talks to Spring AI, and if you get to a bad row of data, just have it fix it for you and see if that fixes it and lets the job continue. What about Spring Security? Imagine you've got a Spring Security firewall that locks down your application, but when it sees a number of successive suspicious logins from the same user from different countries, that should be a red flag. Like, I shouldn't be able to log in from both San Francisco and from France in the same 1 minute, right? There's no way I'm in both places. And so maybe that should be flagged. AI can detect that kind of pattern. I mean, there's some amazing possibilities here, right? We're not going to take advantage of all of that, but we are going to do a little bit. We're going to use the AI support here to write a little story, okay? So let's create a story here. We'll return that as JSON. So story, here we are, return map.of story. Good. All right, there's our story. And we're going to inject the chat client from Spring AI. So I'll inject that there, and I'll create a prompt. Voila. And I'll get a response from the singularity. There, I'll say call, perhaps passing in the prompt, and then pass in this response, okay? All right, so there's this. in this prompt, I'm going to ask it for some help. By the way, I am using in my build here. Remember, I selected on start.spring.io. I selected the Spring AI Spring Boot starter, and now here on my in my properties, I'm obliged to specify an OpenAI API key. Well, friends, I've already done that off screen. I exported an environment variable off screen before I started joining this session, right? So just trust me, it's already been done. That's already out there. So forgive me for not leaking my AI credential. Just trust me, it's already been done. Okay, so now let's send our prompt. Okay, dear Singularity. It's very important to be polite. Okay, it's very important. The machines will remember. I've seen Terminator. I know how this goes. Be polite. It'll pay off. So, dear Singularity, please write a poem about the amazing Java and Spring Boot developers worldwide, nay, galaxy-wide. And, dear Singularity, please do so in the style of famed children's author Dr. Seuss. Dr. Seuss, of course, one of my favorite doctors, along with Doctors Who, Strange, Niepaus, Sire, DeVolder, Pollock, Subramaniam, etc. And then let's see, cordially, Josh. Okay, so I'm going to ask it to write a poem about a particular topic and give me a response. I'll then make the call to the LLM. That'll give me a string response back, and I'm going to then return that as part of this JSON structure. So now, again, I've already run the program. I'm not going to restart it. I can just use DevTools there. It's already restarted, so 0.2 seconds to restart with DevTools. So now I go here, localhost story time, and I can drink some coffee. Oh, that's so good. Oh, the Java developers, so clever and bright, creating Spring Boot apps that take flight. From Earth to the stars, they code with delight, their skills shining like a beacon in the night. In galaxies far, far away, Java developers are here to stay. With Spring Boot in hand, they code and play, creating amazing apps every single day. They're like Lorax, speaking for the trees, but instead of nature, it's code that they please. Their algorithms dance in the cool breeze, creating wonders that never cease. So here's to Java developers so skilled and true, creating magic in everything they do. Their talents are endless, their passions shine through. We salute you, developers, in all that you pursue. So code on, Java developers, reach for the stars. Your talents are boundless, your potential so far. With Spring Boot by your side, you'll go far, creating wonders that truly are bizarre. Amazing. Amazing what we can do with AI today. It writes poetry. It's amazing. But, and again, I'm not begrudging it the time it took. Okay, I couldn't do it any faster, but it did take a long time, right? I made the request, and then what happened? I sat there and I had time to drink some Java while waiting for my Java, right? And yeah, so it took a long time, right? And that's fine. Again, I'm not upset about the time. We need to think through what the implications are for our system, right? We've got a Java program. We have a servlet container underneath the hood. We're using Tomcat, although we could use Undertow or Jetty or whatever. And we have a servlet container, and normally it's a one thread per request model, isn't it? You make a request to the HTTP server. That HTTP server invokes our servlet, which is the Spring MVC dispatcher servlet. That servlet in turn invokes our controller, and that invokes the method in our controller, and then that in turn does what? Well, that in turn makes a call to OpenAI via the chat client implementation that we injected. And behind the scenes, down deep in the bowels of that code, it's making a network call, and it's getting back an input stream with the bytes representing the response from the OpenAI API endpoint, right? And what happens when we read those bytes? Well, it's a network socket. So hopefully we get all the data and it's quick. But, the internet is slow sometimes. There might be volatility in the network, right? Things can fail. So we want to make sure that we get the response as quickly as possible, but sometimes that's not guaranteed. Sometimes you might not get a response back at all. And what does that portend for you if you're assigning a thread waiting for those bytes to come back? Well, it means that you might actually lose that thread for a little while, right? And this isn't such a big deal in of itself, except that threads are precious normally, right? Threads take up RAM. There's a connection. Each Java Lang thread that you create historically corresponds to an operating system thread. And there's bookkeeping associated with each operating system thread, about 2 megabytes of metadata that has to be kept and maintained for each new thread you add to the system. This is expensive, right? And it doesn't scale. So this blocking operation is the problem, right? This input stream.read. What that means is if I call input stream.read, I don't get a byte back until I get the byte back. And if the byte comes in a nanosecond, great, I get the byte and I move on. But if the byte comes a week from now, then that thread is stuck waiting for those bytes to come back, unless I specify a timeout, right? Which I sure hope you did. But either way, you don't want to be in a situation where you're waiting and waiting and waiting in perpetuity for data that may or may not come, right? And if you are waiting for the data and you don't mind waiting for the data, you still don't want to lose the ability to process other requests while you're in this wait state, right? It makes no sense. And yet that's exactly what happens. We are blocking and therefore we are waiting. Blocking is the enemy. And there are several places in Java where we block when we use those methods. Output stream.write, input stream.read, thread.sleep. These are things where we can sit on a thread and just monopolize that thread, but do nothing. And this is a big problem because most services are IO bound. You log into most services in production, you'll see that you've got a very idle CPU. Most of the time, your services are, if they're IO bound, such as web services, they're going to be in a wait state. You've got more traffic than you've got threads to handle the traffic usually. And this means that you're not maximally reusing the CPU that you paid a lot of money for, right? That CPU could be doing more work, but it's throttled by the number of threads that you've got in the system. So what can we do? Well, we can avoid blocking, right? And we can use React, but these are different paradigms. People sometimes don't want to do that. So instead, you can use virtual threads in Java 21. And to see what these things in action, I think it's worth a quick example here that I stole shamelessly from my friend and mentor, Java developer advocate, Jose Pomar, right? He's at Oracle, just a legend. Actually, he's here in France. He's from France, so I can say merci, Jose Pomar. And this example is a very good example, a very simple example. Let's imagine I'm creating 1,000 threads, okay? And so for var I, 0 I is less than 1,000 I plus plus, okay? And now I've got a bunch of threads. I'm going to create a new thread. I'll say thread.ofPlatform. That's the traditional thread that you would have gotten anytime in the last 28 plus odd years, okay? So threads.add th, voila, okay? And finally, I'm going to go through and I'll say for var t threads, t.start, okay? T.join, very good. And then finally, I want to print out the names of all the threads as well in the system. So names equals new concurrent skip list set, okay? Names like that. Okay, and so why am I printing out the names and why am I putting them in a set? Well, remember, sets deduplicate their entries, right? Their elements. So if you have the number 1 in a set 2 different times, when you iterate over it, it'll only visit that set 1 time, right? You'll only see the number 1 in that set 1 time. And so I'm going to make sure that I'm capturing the name of the current thread, but only if I'm on the first of the 1,000 threads, okay? So if I'm on the first one, then names.add thread.currentThread.toString, okay? And then I'll block for 100 milliseconds, okay? So now I'm going to copy and paste this code. 1, 2, 3. So I've got 400 milliseconds of sleep, right? 400 sleep operations in the code base already. That's really good, right? I'm sleeping 400 milliseconds. I've got 1,000 threads. The CPU is going to try, the runtime is going to try and share, but basically, I'm stuck, right? I'm waiting for those threads, and eventually somebody's not going to have enough CPU time, so they're going to have to wait. It'll take more than 400 seconds for everything to run. Okay, so I'm only doing it for the first thread. I'm going to run it. Command Shift F9. There we go. And you can see the program starts up, and yeah, here it's very clear. Physics hold. The universe is as we expect, right? The reasonable thing to assume is that if you are on a street like Market Street in San Francisco, and you're underneath a lamp, and you see the sign, it says Market Street, and then you walk 10 meters, 20 meters on Market Street, then it's not unreasonable to say that you're still on Market Street. That's how the physics of the world works, right? You started on Market Street. You never left Market Street. You're still on Market Street. That shouldn't be weird. But now, friends, thanks to a new feature in Java 21 called virtual threads, well, things get a little weird. You don't always end up on Market Street. So here, now, I'm on virtual thread 2216, that's Market Street, virtual thread 2216, virtual thread 2216, and virtual thread 2216, but I'm on 4 different actual operating system threads now, right? So throughout the life of that program, the runtime, it saw that I'm going to sleep for 100 milliseconds. It said, oh, okay, I'll set an egg timer, and in 100 milliseconds, I'll come get you and put you back on another thread so you can continue executing. But in the meantime, I'm taking you off of this thread, and I'm going to let somebody else in the pool use it instead because they have a need for it and you're not using it, right? And this is all transparent to us. I did nothing save for change the constructor between virtual or platform threads, right? That's all. And of course, most of us aren't creating threads in a low-level way like that anyway. Most of us are doing something like new virtual thread task executor, right? This is not a thread pool, by the way. This is a task executor. It's going to create a brand new thread each time. Why not? It's cheap now. You can create millions of threads in a single JVM with no discernible loss of scalability or capability, because remember, the runtime will automatically handle switching between them. So even though you've got a million Java threads that are running on different carrier threads or actual operating system threads, okay? And so even here, though, I don't want to specify executor services everywhere I need to, right? There's a lot of places in Spring Boot where I could define a bean of type executor to override a default executor being used in the system. But there, I don't want to do that. So if you're using Spring Boot 3.2, you don't need to, right? Just do that. Spring.threads.virtual enabled equals true. And now we will do it for you. We'll automatically make sure that your web server and all the other useful places to have a thread pool specify a thread pool that uses virtual threads, okay? Like this. So now you can get the benefit from that. Friends, I recommend that you go to your management and say to them, look, I have a bold, audacious idea. I'm gonna help us improve our scale considerably. But I want the money that we get, that we recoup in our cloud infrastructure spend. I want that money deposited into my bank account, and I'm going to need 2 weeks, right? Get them to agree to that, and then just disappear for 2 weeks. Set this property, move to Java 21 and Spring Boot 3.2, easy, right? And then deploy and say, okay, it's done. Where's the check, right? I'm sure this is going to be a good idea, right? Or probably not. I don't know. It's a great idea, though. Look at this. These virtual threads are incredible. Check. Yeah, I can't give you benchmarks. I can't tell you the exact numbers. Try it for yourself. But there's no doubt if your service is IO bound, then this will be considerably more scalable. It'll allow you to scale to levels that you might have only gotten to had you used reactive programming, right? This is a huge deal. Oracle has done us a huge favor with this. This is free money. That's why I say you really should be you should be on Java 21 or later. Nothing before that is ever worth doing ever again, right? An amazing result. Thank you, Java. So now we have our application. We're talking to the Singularity. We've got a web app babysitting our database. We've got the Docker Compose support and the dev tools. We're moving quickly. We're making changes, seeing those changes reflected instantly. We got AI. We're doing quite good. I think it's now time to focus on getting this thing to production, my friends. And here, some common questions that arise are, first of all, how do I build a container for my application? Yeah, use build packs. build packs are a great way to build a OCI or Docker image out of your application. And they're a cloud native computing foundation specification. They work really, really well. Yeah, friends don't let friends write Docker files. Don't do it. Be the change you want to see in the world. Do the right thing. Use build packs. So I'm not going to show you that because we don't have enough time. It's an old thing from years ago that we support in Spring Boot, but I just want you to know it exists. The next thing that we're going to have to answer for, the next question that we're going to face when we move to production is, how do we package the application such that it's more efficient, more performant, right? We saw that Java is already very efficient and very performant, but just how efficient and how performant? To answer that, I think it's amazing to look at this blog from 2018, which is before the COVID pandemic, so BC, right? And you can see it says right here, May 20th, 2018. And this blog is based on a research paper which asks the question, which programming languages use the least electricity? And the results, I think, my friends, are pretty interesting. You've got a table here that shows the normalized global results for energy, time, and memory. And the results, again, really interesting. Look at the energy column. It says that C is the most energy efficient programming language for machines. Very important that we be on the same page there. Not for people, for machines. Then we got Rust. Quite good. Good job. Well done. Zero cost abstractions. Good on you. Then we got C++. Ooh, disgusting. Moving on. Then you got Ada. Nobody cares. And then you have Java. And Java is 1.98. So we can say, just rounding up a little bit because my brain is not so good with math, smooth brain, we can say that Java is 2.0, okay? And C is 1.0. So let's just do some simple math. We can say that C is twice as efficient, energy efficient, as Java. Or, put another way, Java is 1/2 as energy efficient as C. That said, it's still in the top 5, right? We're doing quite good. Look at all these other languages and then compare them with Java. Java is the only one with that dynamic of behavior and that dynamic of runtime that's in the top 5 list. Everything else is a very different thing indeed. And look at the other entries in this list. Swift, of course, if you're using anything from Apple, and I'm sitting here as I talk to you right now, I've got an Apple Watch, an iPhone, an iPad, and a Mac laptop. I'm definitely wearing a lot of Apple kit. And they're all running a language that is much less energy efficient than Java, which is what Android is using. Interesting. They have Haskell, they've got C#, they got Go, Away, you've got JavaScript and TypeScript. I don't understand. How is this? What happened? This is 4.4, that's 21.5. Why is TypeScript almost 5 times less efficient than JavaScript? I thought one compiled to the other. Look, friends, if you, like me, prefer the safety blanket of TypeScript that allows you to sleep at night thinking you have types in your code base, even though you don't, then you and I are in the same boat, and our boat is sinking. That's the problem here, friends. I don't know what happened here. This needs to get better. Let's move on. These two languages, the less said about which, the better. Moving on. Then you have these two, JRuby and Ruby. Friends, JRuby is Ruby written in Java. And then Ruby is Ruby written in C. And yet the JRuby implementation is almost 1/3 more efficient than the Ruby implementation. Absolutely amazing. Amazing, right? That's because the JVM is boss sauce software. It's just an amazing piece of kit, and it's doing amazing work here, right? Remember, JRuby came later. They built it after the C version was already out there and doing its thing, right? And then we get to Python. And friends, this makes me really sad because I quite like Python. I've been using Python since the 90s. I was learning Python when Bill Clinton was president in my country, and yet these numbers I find not acceptable, right? 75.88. I'm again smooth brain, not so good with math. Let's round up. Let's call that 76. Okay, I don't know what 76 divided by 2 is, but you know who does? Freaking Python. Let's go here. 76 divided by 2, so 38. So that's That means that if I wrote a program in Java and that program created energy and that energy got trapped in the atmosphere and raised the temperature just so much as to make it inhospitable for one tree, which then dies, one tree, then that means an equivalent program in Python would kill 38 trees. That's a forest. That's worse than Bitcoin. We need to have a conversation about this. Not now, surely not now, but we do. Somebody's got to talk about this. That's not good. That's not good at all. What were we saying? All right, Java. Anyway, my point is Java is amazing. Okay, really, really effective, efficient, wonderful language. That said, what are the two reasons it is so efficient, right? Well, one is, of course, the Java programming language garbage collector, which is an amazing Java garbage collector, an amazing thing. That said, I do take issue with the notion that the Java programming language garbage collector is the original garbage collector from the original Java garbage collector. It is not. I think that honor probably goes to this person. Her name is Jesslyn. She works at she used to work at Fan House. I guess she's at Meta Open Source, and she is from the island of Java, Indonesia, and she is the Java garbage collector. Now, friends, she's probably the first. I don't know. Probably she has the honor of being the first Java garbage collector. And look, friends, most of the time the internet is a cesspool. But look at this. This is great, awesome humor because it relies on the intersection between geography, programming languages, garbage collection, and Indonesia in particular. Just an amazing post. Also from 2018 BC. So that's one thing that the Java programming language has, which is the garbage collector. Okay, that's part one. The other thing is the just-in-time compiler. The just-in-time compiler allows me to write code and I can get away with it, right? Basically, the just-in-time compiler allows me to take code and have it for some parts of my code base that are frequently accessed. I can turn it into operating system and architecture specific native code. And the result, of course, is it speaks for itself. I mean, we just saw what JRuby looked like, for example. Java does an amazing job there. And the question then is, well, if the just-in-time compiler is so good, then why not proactively compile everything into native code? And you can do that now, right? You can actually do that with GraalVM. GraalVM is an open JDK distribution that provides some extra utilities, some very nice utilities, including a polyglot virtual machine and a native image compiler. And so the only problem with GraalVM, of course, is that it, just like the just-in-time compiler, struggles with dynamic things like reflection, like serialization, like JNI, like JDK proxies, because it doesn't want these things because they violate the hermetic seal that the type system is expecting when it's moved over to native code. So you have to tell it. It's not a big deal, but you do have to tell it about where you're doing these dynamic things. And usually you do that in terms of these JSON configuration files. I have two problems with these JSON configuration files. First of all, I just don't like the word. It just sounds stupid. I speak French as well, and in French you would say JSON, which I think sounds markedly cooler. I think we can agree. That's part one. Part two, there's other people. I was in Taiwan, and they speak Hokkien there, among other languages, and there they've got the word jingsong, which I think means happiness, and that sounds cool too. Either way, I'm tired of this. I'm team JSON, but you can pick your own team. Doesn't matter. Let's move on to a different format. That's part one. Part two is there's just a lot of it required, and I don't have enough time to write it all. I don't even have enough time to finish this talk. So I'm going to let the Spring AOT engine do the work for me, okay? So I'm going to go here on the command line. I'm going to kick off a native compile. I'm going to skip test because I didn't write tests. So we're going to go ahead and run that. And this is going to take a little while. That's the only problem is it takes a little while because it's doing a very deep analysis of the entire code base, all the libraries, all the code in the JRE and so on. And frankly, I get bored. I kind of understand now this famous XKCD cartoon, which posits that the #1 program excuse for legitimately slacking off is My code is compiling. Here we see two swashbuckling programmers. The boss says, hey, get back to work. Compiling. Oh, okay, keep going, right? I get this joke now. I thought this is just the C++ people. And frankly, I just get bored. If I'm not swashbuckling, I'm doing something. But the problem is that it's not enough time to go like take a walk or make some coffee. But it is long enough that I get distracted and I start to hum music in my head. I start to hear music in my head, theme songs, elevator music. And at one point I got frustrated and I said, wouldn't it be great if everybody could hear elevator music? So I went to Oracle and I said, please play elevator music during the native image compilation process. I said, I already hear elevator music in my head while I do these sometimes long-running compilations. I'd just like everybody else to hear it too. Thank you in advance, and I appreciate your amazing work. And I got some great responses, including this one, which is from it's elevator music from the James Bond GoldenEye Nintendo 64 video game from the 1990s. I got this one, which suggests that we could use beeps like a microwave. That makes perfect sense. And of course, this one from yet another one of my favorite doctors, Dr. Niephaus, on the GraalVM team, Alina's colleague. And he said, thank you for your feature request, Josh. The problem with playing music during the compilation process is that it's just fixing the symptoms, and we've been and are still working on the cause, making GraalVM more efficient in terms of time, memory, and CPU consumption. Go on. Anyway, he continues, I have prototyped a -- Josh long mode. So what this would do is you'd run native image -- Josh long mode. You'd hear music. This is a picture, but don't let that stop you from perceiving that there's music playing. And then you're wondering where the music's coming from. So it says music brought to you by Josh Long, but you're still waiting. So now you want something to like look at or whatever. So now that shows up. I think this will get merged any day now. I'm sure it will, right? It's going to be a great addition. Anyway, where were we? Oh, right, the compilation. Yes, so that actually, that is very awkward. That finished like 2 minutes ago. Okay, so target, here's the binary, okay? You can see it's got everything. It's a statically contained, statically linked binary. Oops, I've got the application running on the same port already. Go here again. There we go. So there's the application. Virtual threads starts up in about 1/10 of a second, right? More interestingly to me, of course, is the process identifier, PS-O RSS. That's the RAM, and it's measured in kilobytes. So divide by 1,000, and you get 118 megabytes for an application that talks to the Singularity, has a web server, a data access framework, and all of the JRE that it needs, and all the libraries in the class that it needs, and it still does all of that in 118 megs. That's an amazing, amazing result. I'll bet you have Google Chrome tabs that take up a lot more than that. My friends, there's never been a better time to be a Java and Spring developer. I hope I've so persuaded you. Thank you so much for your time. I'm happy to answer questions now. If there are.
Yes, I figured GraalVM will be a great time for me to jump in and see if we can take some questions. There are already some, and I have some prepared myself. Let me just, all good. So we have some time for questions. If Josh can stay with us for a couple more minutes, and please use this chance to ask any questions you might have about Spring Boot, about this session, or even in Spring Boot in general. Use this chance to have your question answered by Josh himself. So let's look at the questions, and I have one start over here from previously when you were talking about recent Java features. And this question is, let me bring it on stage. So can you comment on switch statements and then other or not scenarios where you would rather go with ifs rather than switch structures?
I mean, yeah. So if else has if you don't have a known exhaustive set of states that you want, then go with an if or else or whatever, If you're just trying to capture one case out of a million, then your if is going to be your best bet. But if you have a known set of states in which you can navigate, then let the compiler do its magic. Remember, switch statements are faster than if, right? Just benchmark it. You'll see it's amazing. In C, in Java, and everything, it's just built that way. The compiler can do things to jump straight to the branch, so it's based on the pattern. So, I'm not trying to say don't use if. I'm just saying know when to use switch. Switch is nice again. They fixed it.
Totally agree. And also great developer experience, great maintainability, readability, all of that.
Yeah.
Okay, we keep getting questions. What about this one? So will virtual threads work with Webflux?
I don't think so. I mean, look, you already get the benefit of it, right? So if you're on reactive, continue doing it. You're fine. You don't need to. Nothing has changed for you, right? You've already got this. You've got better performance than virtual threads, and you get ease of composition, and you get errors as data. So you get 3 big benefits, whereas virtual threads only gives you that first feature, which is scalability of threads. But if you're not on reactive and you don't want to make the functional programming jump to do reactive, then just please move up to Java 21, enable virtual threads, and you'll get basically the same kind of scale. You don't get those other 2 benefits, but that's okay. Most people don't care about those other 2 benefits anyway. Certainly, if you're looking at that versus a full rewrite for reactive, I think for a lot of people the choice is pretty clear. What else?
Cool, thanks. Yeah, there is this one, and they don't specify the benefit of what, but I think this appeared around the time you were showing GraalVM. So I can assume it's about the GraalVM, or if not, if you mean something else, please add more details and we'll be happy to answer. So for
okay.
GraalVM, I can also let Josh take his sip of water and answer it for you. So you might do GraalVM-native image, what Josh did, for startup, for memory usage, for smaller packaging, even for improved security on top of your normal Java security. Briefly that, and you can see way more benefits in the talks and blog posts, etc., that we were giving. Okay, what about this one? What is the best way to start with Spring Boot?
Okay, obviously start.spring.io, but if you want a quick, easy read, go to spring.io/guides. If you want full in-depth training from people on the Spring team for free, spring.academy, okay? And then that's the inception question. That's how do I build a brand new from scratch Spring project. And obviously I have a YouTube channel. Check out the Spring Source Dev YouTube channel, or mine is Coffee Software. But the next question is also kind of interesting, which is, I've got a Spring Boot application. It's now getting old. I want to move it forward. What are the best tools to operate and upgrade old Java Spring Boot projects to a newer version? Check out 2 tools, the Spring CLI and Open Rewrite. And these things, Spring CLI uses Open Rewrite, and it can integrate with that. Does AI Java or Spring system? Yes. By the way, you hear people talk about Python and AI as though they are synonymous. You don't need Python to use AI. Remember, in the same way that I don't need C in order to use a SQL database that's written in C, right? I can use Java. You want to integrate with your AI. You don't want to build your own. Nobody wants to build their own SQL database either, right? And here, Java is second to none in terms of options, in terms of potential. Just use Spring AI, and you can integrate with all these different things. Bring all these use cases to your users, right? Imagine every app you've ever built. Now you've got a semi-autonomous agent that can handle 90% of the user-facing tasks for you. I mean, really a big deal.
There are so many great libraries. So I will just add, Josh mentioned Spring AI. There is also Chain4j. There is also Stable Diffusion for Java. So tons of libraries, even in the Java ecosystem. Indeed, you can just use any of them.
Yep.
So do you want to talk about sealed interfaces, this one?
Yeah, well, if you get to a point where the types aren't, if you get to a point where the types need to be expanded, then just permit more. Just add one more to the permits case. Also, there's a difference between writing code as a library for a framework versus writing code in an application. Obviously, if you're writing a framework, then yeah, you want it to be open for extension, right? So you want those to not be sealed. Like Spring Framework, we have a bunch of interfaces. They're meant for you to openly extend, right? Yeah, so just know your use case. If it's an app though, and you control the code base, and there's nobody, no other consumer, then that should be fine. Thank you for coming, and thank you, Kim and Alina, and Mark, for all the amazing work you did. I appreciate you making this session available for me. With the virtual threads, do we still need to use Spring Webflex? If your use case is just scalability, then they're equal. If you want ease of composition, which is I think a cleaner programming model, and you want errors as data, then you can use reactive. But if you're already on non-virtual, if you're on non-Webflex, if you're using blocking IO, just upgrade to virtual threads. How can we improve ourselves in Spring? Just do those things I just mentioned earlier. Spring.io/guides, Spring.academy. Wonderful session. Thanks for the insight. Thank you. I appreciate that. Can you share some insight on Activiti and what are the possible use cases for it? Yes. Well, first of all, these days, the people that worked on Activiti are now part of Flowable. right? And so check out Flowable. I did a Spring Tips video on Flowable. Look for Spring Tips Flowable from like a couple years ago. It's the same company, same team, same code base even. They just forked it. And yeah, it's a workflow engine. So anywhere we have long asynchronous processes that thread between people and autonomous actors, agents, software services, whatever, use a workflow engine to manage that state. It's awesome. Alina, here's a question.
Yeah, that one might be for me. I know that you want to pass this one to me. So about GC option in GraalVM CE, indeed, in GraalVM Community Edition, the one that is open source, the option that is available for GC is serial GC. But we are working on improving that and extending the options you have in CE. But still, I do encourage you to give Oracle GraalVM a try. So if you want to have good peak performance, G1 GC is very good, and it's probably your best friend. So I do encourage you to give it a try. It's free to use in production. I think I saw Josh demoing Oracle GraalVM, so it's not as scary as you might think. Give it a try, check out the performance. I think you'll be quite happy. And we are getting a lot of questions about resources, so maybe we can just tweet afterwards the links where you can learn all the latest and greatest stuff about Spring and improve your skills.
Actually, can I show one thing?
Yep, go ahead.
I'm not going to write code, but I'm going to show. So I did actually, if you want to learn about GraalVM and Spring Boot in particular, friends. Okay. Go here.
Too early? Okay.
Did I share my screen?
Yeah, you're screen sharing. You can just open the page. Yep.
So I wrote a book called Everything You Never Wanted to Know About Spring Boot 3 AOT, right? It's the
oh my God, that is so good. I can confirm. I read that book twice. Love it. Very good read. Go check it out as well.
50 pages, very quick. If you don't want to read and you're more of a visual video person, then you can watch the video. They're both free. The video and the book are free. This is a Spring Tips video that I did introducing Spring Boot 3. It's 2 hours, so it has everything. It's like in-depth as can be. So check out those resources. All right, then stop screen. Okay, good.
Okay.
So
yeah, let's answer the last couple of questions, and then I think we need to wrap up. So I'm not sure what's this one about.
Very, very good question. So there are some cases where virtual threads don't work, right? And when I say don't work, I mean they still work as well as threads used to work in Java 20, but they don't work well in the virtual thread sense. So what they mean is, imagine you have a thread. It's a virtual thread. In the thread, you do synchronized on a monitor object, like, whatever. And then in the synchronized block, you do input stream.read. Well, in this case, the memory has to be consistent. And so the JVM won't automatically move you from one thread to another because you're synchronized. So you're doing input stream.read, you're blocking, but it won't do anything. It'll behave just like it did with Java 20. So it won't give you the benefits of virtual threads if you do that. In that case, do the input stream.read before the synchronized block. Move it out of the synchronized block. Don't ever do it inside of a synchronized block. And as long as you do that, you're fine, right? If you do that, it'll fail, but it fails in the same way that when an escalator stops working, it just becomes stairs, right? It still works. It's just not going to be as good as virtual threads. It'll be as good as like regular threads from Java 20 and earlier. Ktor versus Spring Boot. Ktor is just a dependency injection framework in Kotlin, whereas Spring Boot is a whole world of features and integrations and opportunities. So, but they both support Kotlin, and that's good. Hey,
amazing.
Mark.
Okay, thank you, Mark. Again, that's our hint that we are over time, right?
No, I just wanted to hang out and chat with you folks.
Oh,
I missed you. I'm gonna see you in a few weeks.
So you're over in France at the moment. Where can people see you coming up?
I'll be at Devox UK, which is just on the other side of the channel there.
Now, I have a rumor that
a couple of weeks, right?
Alina, you're going to be there as well, right?
Yes, all of us will be there.
I had this rumor that Josh is sharing a stage with Venkat during Devox.
I'm going to be the one who brings him coffee. Yeah,
we need to build a bigger stage, my friend.
Well, he's got a lot. He doesn't even drink coffee. That's the worst part.
Oh no!
I think he does actually. No, I don't know. I'm gonna bring him as much coffee as he wants. I'm the that guy, the person that comes over with the big poof ball for the makeup, like like that. I'm gonna be that guy, to powder to dab the sweat and all that stuff when he's doing his presentation.
And you'll be talking about virtual threads, right?
Oh yeah, it's gonna be awesome. Yeah, check it out. Like I cannot wait. It's Dr. Subramaniam, one of my favorite doctors. I mentioned him and Doctor Who.
That is going to be great. I want to say a big thanks to Josh, also to Alina for being an epic host as well. Thank you so much. Our next session is going to be on the 23rd of May, same time, same place. Matt Rabel is joining us, the one and only Matt Rabel. He's going to come and talk about reactive Java REST APIs, which is great. In the meantime, if you are around the world, where you probably are, and you want to go and see a real in-person show, there's some great stuff coming up. April 25th, 26th is Brazil JS Conf over in Porto Alegre. I'm going to miss loads here. DevOps UK, we've already mentioned, May 8th to the 10th in London. JCon Europe, May 13 to 16 in Cologne. GeekOn over in Krakow, which is May 15, I think. Vox Days Brussels, May 21, 22 in Brussels. It would be a bit weird if it was called Vox Days Brussels and they put it on somewhere else. But there's loads of cool stuff out there. And also, please come and join us again next time round. As I say, Matt Rabel's joining us next time, and stay tuned because we're about to announce the next lineup of great sessions from June onwards as well. So thanks everyone for joining us. Thank you again, Josh. Thanks, Alina. And thanks everyone for your great questions. Take care. See you soon.
Thank you so much, Mark, Kim. Thank you. See you.
Thank you too. See you soon.
Bye.